Loudspeaker placement is a subject that often veers into the realm of mystique in the audio world. The complexities of acoustics, particularly within the confines of a living room, may seem daunting. Nevertheless, with the help of fundamentals and methodological approach, reaching an optimal loudspeaker placement becomes a feasible objective. The essence of loudspeaker placement breaks down into two simple steps that can be practiced by clearly understanding the principles involved and practical techniques to optimize sound performance within any listening environment. Step 1. Preliminary speaker placement. Triangle configuration. Position the two loudspeakers and the listener to form an imaginary triangle, ensuring that the distance between the speakers is equal to the distance from each speaker to the listener. This configuration fosters balanced stereo imaging and optimal soundstage reproduction. Also, it is advisable to position the speakers ideally at least 2 to 3 feet away from any large wall surface in the room, which may sometimes prove challenging to implement in real-life environments. Height alignment. Align the height of the mid and high speakers with the listener's ear level at the listening position. This ensures that sound reaches the listener at the correct angle, preserving spatial cues and timbral accuracy. Tone adjustment. Depending on room acoustics and speaker characteristics, experiment with tone adjustments to optimize sound dispersion. While aiming speakers directly at the listener may offer the brightest sound, subtle adjustments in tone angle can enhance stereo imaging and tonal balance. Step 2. Room acoustics adjustment, a register-specific approach. Central to this approach is the segmentation of the audio spectrum into distinct frequency ranges, lows, below 200 Hz, and highs, above 600 Hz. Low frequencies. For low frequencies, room modes and standing waves are the primary concerns. To minimize their impact, the insensitive directivity of low-frequency propagation can be taken advantage of. Also, a strategic placement of furniture can attenuate the standing waves and more balanced bass can be reproduced. For optimal bass reproduction, room modes must be controlled. Every room has its own set of modes, and not all room modes can be tamed. There are many theories and reasonings revolving around bass management of a listening room, but none of them proved universal. Finding the ideal solution for your specific room requires time and dedication. Investing more effort usually pays off, but only with a diminishing return. You will always need to compromise at some point in room mode control. If the bass management exhibits clear limitations that persist despite all possible relocations, considering a dedicated subwoofer could make your life a little easier, just because the separate subwoofer can more freely move around without altering the triangularity, wall clearance, or the height settings of the main stereo channels. Early reflections, which occur when sound waves bounce off room surfaces, have the potential to impact stereo imaging and tonal accuracy. To address this, it's advisable to conduct empirical testing using basic tools like mirror and tape measure to pinpoint early reflection points. The mirror and tape measure can be used in the following manner. Use of mirror. With the assistance of an assistant, position a mirror flat against one of the room's walls. Now, move the mirror horizontally and vertically until the listener, from their seating position, can see the reflection of the loudspeaker in the mirror. The point on the wall where the mirror reflects the image of the loudspeaker is indicative of where early reflections occur. This is because sound waves, particularly mid and high-frequency ones, behave similarly to light waves and bounce off surfaces in a similar manner. Once the reflection point is identified, mark it on the wall using masking tape or a post-it note. Use of tape measure. First, measure the distance between the loudspeaker and the listening position using a tape measure. This measurement represents the shortest path that the sound emitted from the speaker travels to reach your ears, or the path of the direct sound. Next, measure the distance from the loudspeaker to the previously marked reflection point on the wall. Then, measure the distance from the marking point to the listening position and add it to the distance you just measured. This combined distance represents the total path length that the reflected sound will travel before reaching the listener's ears. Finally, calculate the difference between the two lengths. This difference is responsible for the early reflection delay. If this difference is less than 1.5 to 2 meters, it indicates that the early reflections arrive at the listener's ears too quickly, potentially causing interference with the direct sound. Also, by strategically placing acoustic panels, furniture, or drapes, enthusiasts can customize solutions to enhance soundstage clarity and imaging precision. The procedure can be replicated for the other surfaces of the remaining walls if necessary, resulting in a collection of early reflections within individual listening spaces. Moving on to high frequencies, it becomes crucial to consider early reflections and their effect on stereo imaging and acoustic clarity, which can be achieved with the aid of straightforward tools and practical methods. It's possible to discern the impact of early reflections, as mentioned earlier. Speaker orientation optimization. Last but not least, fine-tuning speaker orientation is crucial for optimizing spectral balance and stereo imaging fidelity. It is important to experiment and adapt to individual room acoustics and to explore various tone angles and dispersion patterns to achieve the desired sonic character. Conclusion. The outlined procedure provides a concise guide on positioning stereo speakers effectively in a typical listening room. This two-step approach to loudspeaker placement presents a comprehensive yet user-friendly framework for enthusiasts aiming to enhance their audio setup. By grasping fundamental room acoustics and prioritizing practical methodologies over complex theories, listeners can attain remarkable sound quality in their listening spaces, liberating the full potential of their audio systems. Additionally, optimizing speaker location for optimal frequency response, particularly in mitigating the effects of room modes and standing waves, will be explored in greater depth in an upcoming video. Thank you for watching.